Hi, I'm Sarah Tyke, host of the Interested Reader podcast. Each week I'll bring you a short lesson in physics or astronomy, followed by a brief overview of what's happening out there in the universe. We'll also merge the wonders of science with the depths of spirit and discuss the metaphysical and spiritual aspects of our universe and ourselves. Come with me as we explore stars and souls, the intersection of science and spirit. Hi everyone. Welcome to the Interested Reader podcast. This is episode 18. We are going to talk about the nature of light, and we're going to do a little bit of space weather stuff, so I think that'll tie in nicely to this topic of light. It's always been one of my favorite subjects, light and optics. It was one of my favorite things to study in physics and then to teach it when I was a TA. I just find light to be very fascinating. So first we'll do our kind of daily numerology. So today is July 15th, and the number for today is 4, which is associated with dependability, stability, loyalty. But this number is also very unlucky in some Asian countries. They actually call it tetraphobia. Kind of like how other like Western countries have 13 as their unlucky number. In some countries, 4 is the unlucky one. And 4 is one of my favorites. It is also associated with the zodiac sign of Cancer. 0 is actually my favorite, or 2 is my favorite number, followed closely by 0, and then 4. I love 2. So just a reminder of how we calculate these numbers. This is a Pythagorean system. So you just take the digits of the date and add them all up, and then you keep reducing the numbers down till you get one digit. So if we add up all the numbers in today's date, we get 22, and then you add the 2 plus 2 and you get 4. And just a reminder that the year 2025 has a number of 9, which is associated with the completion or the end of a cycle, transitioning to a new phase. It's also a connection to inner wisdom and spirituality. I've always find that to be kind of synchronous, because this year I've really been trying to, just get better. Try to have more time for prayer, meditation, just trying to kind of, accept where I am in life. Still, obviously, you still want to move forward and improve and get better, but just kind of accepting the things that you can't change. There are certain aspects that are like, it's done. There's no going back. That old life doesn't exist anymore. So it's time to accept that and work with what we have. Alright, so then first we have our quote of the day. So this comes from Jim Rohn, who, I don't know much about him. I know he's a motivational speaker. I haven't listened to a lot of his stuff. I listened to other people who listen to him, and they often bring him up. So the quote is, "Learning is the beginning of wealth. Learning is the beginning of health. Learning is the beginning of spirituality. Searching and learning is where the miracle process all begins." And I do like that one just because, obviously, my goal with this podcast is to teach people. And while I'm teaching, I'm also learning. And, it's always been said for ages that, you should always be learning something new. I think my grandfather always did. I know he always did some sort of like math every single day, into his 80s and 90s, just to keep his mind working. He'd just basically sit down and just do math problems. They're simple math problems, but, it's just something to keep his mind working. And I know my mom always said that you should be learning something new every day. And basically, anytime we made a mistake in school, it was never really, who cares about the grade? No one cared about the grade. Except me, I always cared about it. But my mom was always, her only thing was that her first question if we got a bad grade on something, if we failed a test, was, do you know what you did wrong? And if you don't, did you get help? That was all she cared about. She didn't care about the grade. So learning was always a big thing, and always learning from your mistakes and just don't repeat it again. That was kind of the second half of that lesson. Know what you did, and then don't do it again. And of course, learning is, the beginning of spirituality. There's so much that we don't know about everything, the physical world, the spiritual world. So this quote, when I saw it, really struck a note with me. So hopefully, as you guys are listening to this podcast, you're getting something out of it and you're learning something by listening. That is my goal by being here. If you guys ever want to have a specific topic, you can always contact me and let me know. If you have questions, obviously there's Facebook, Instagram, email. So hopefully today you will learn something. So first, before we get to our nature of light topic, we're going to talk a little bit about some space news that's going on. I think the last episode was in June, or was it early July? I don't remember. I think it was in June. So there wasn't much going on as far as stuff to look at in the skies this month. It seemed like there's a lot of what's going on last month. So Titan is still transiting Saturn. So if you have a small telescope, you can see Saturn's moon Titan. You can see the shadow on the planet, which is pretty cool. It was going on last month. It's going to go on for a few more months. I don't remember. I don't think there's really a decent meteor shower. I think there's one that's peaking right around now. I think it's the southern Aquarids. So I don't know how visible they are in the northern hemisphere. And they started last month. So I think we talked about all this in the last episode. So a lot of the same stuff is still going on. There was a buck full moon. I should say it this way. The full moon this month was called a buck moon. And there was something about it in its orbit. I think it was the full moon phase was actually going to be full for longer than normal. So usually, because everything is constantly in motion, because planets are always in orbit, the full moon is like, it's full and then it's like immediately changing to the next stage. You don't see it, obviously. But because it's always orbiting us, it's always in motion, technically, like seconds after it's a full moon, it's already into the next phase. It's already not full anymore. But this month, it was going to be full for a little bit longer. Like, I don't know. I don't remember how long, I'm sorry. But that happened, I think, on the 10th or 11th, so a few days ago. So anyway, so there wasn't much, I don't think, going in the sky that was significantly different than last month. So there is something really cool going on with the sun, so I figured we'll talk about space weather. And the sun, I did an episode on the sun a while back, so if you want to learn more in depth about the sun, you can go back and listen to that episode. Or, again, if you really want to know, you contact me and I'll do another episode on the sun. I love the sun. One of my favorite things. So a couple things that are going on. There's a huge solar prominence that was discovered on July 12th, and there's a super huge coronal hole in the sun, which is really neat to see. All right, so first of all, I'll talk about the solar prominence. So on July 12th, this thing was recorded, and a prominence is a large mass of solar material. So that the surface of the sun is plasma. I mean, that's what the sun is made out of, is plasma, and it's given structure by strong magnetic fields. So here we've got plasma, we've got magnetic fields, and if any of you listen to me, you know that my favorite cosmological theory is the electric universe theory, or the EU theory. Not the European Union theory, it is the electric universe theory. And the basis of that theory is that everything is governed by electromagnetics, because plasma is everywhere in space. It's stars, it's nebula, it's everything. And magnetic fields can travel light years, hundreds of light years, without decreasing. Gravity decreases as it's it's an inverse square law. So 1 over the distance squared, it decreases very fast. Magnetic fields will too if you go away from the field. It's hard to explain without visuals. If you imagine like you have a cable, like a coax cable or something. As long as you're going along that cable, a magnetic field does not decrease at all. It only decreases as you go outside from the cable, like perpendicular to it. Then it decreases as the inverse square law. So you can have a plasma filament that you could think of as like a coax cable, and a magnetic field can travel along that plasma filament essentially forever without decreasing in strength. But gravity doesn't do that. Gravity falls off all the time. It's the weakest force. I mean, between the two. But gravitation has dominated the theory of cosmology forever, and I don't know why, because plasma is everywhere. And here we have in the sun this structure that we're looking at. If you're watching, this structure is the electric universe theory right here. It's plasma. It's magnetics. So why are we not using the electric universe theory on larger scales, and why is it not more widespread? I have no idea. But I'll do another topic about that. I love the EU theory. If you subscribe to the newsletter, I do a little column about the electric universe theory to introduce it. So we just do, like, each month there's a new segment about it. So you can subscribe to that newsletter through the website if you want. But whenever I see stuff like this with the sun, I'm like, of course, it's the electric universe theory. And it doesn't have to apply to just the sun. Anytime you have plasma, anytime you have magnetics. And that's everywhere in space. So, I don't know. We'll talk more about the electric universe as we go on. But this was a good example of it in action. So if the prominence becomes detached from the surface, it can result in what's called a coronal mass ejection, or a CME. And then that plasma just gets blasted into space and travels through space. It often hits Earth. If a sufficiently large one hits Earth, that it can knock down the grid, and everyone's always worried about, these types of things basically taking down the power grid. And then I should have brought this up in here, but there was a Carrington event in the 1800s where this happened, where there was a huge solar flare, and this CME was ejected toward Earth, hit Earth, and it caused such a geomagnetic storm that it knocked out the power. Well, I mean, they didn't have the extensive grid that we do now, but it melted telegraph lines because they got so hot with the extra particles from space. Telegraph wires actually melted. And so scientists are always like, well, that could happen again. I mean, most of the time when you follow things like this huge prominence, it usually ends up being ejected, and it just barely misses Earth. It'll be one of those things where the sun will have rotated just past the direct line of Earth before this thing is shot off into space. So there's a lot of close calls when you start following this. It's a lot of, this could be it. This could be the direct hit, but then it just happens that by the time the thing actually does, kind of explode in this CME, that the Earth has rotated, or is just past the point. The sun has rotated a little bit, and it's not a direct hit. So we get lucky a lot. So on the picture here, if you're watching, this is a picture of this prominence that was recorded on July 12th. And it's pretty cool if you go online. A lot of these pictures are like animated, so they were filming in real time, so you can kind of see the kind of bubbling motion of the sun, and you can kind of see things. It's just like a huge cauldron of bubbling lava. It's really cool. So solar prominences are huge. It's hard to tell, obviously, the scale from a picture, but they can extend hundreds of thousands of kilometers into space. So the largest one on record is 800,000 kilometers, or 500,000 miles, which is just about the radius of the sun. So here's something that's just, in these big loops, these arches off the sun that can extend, the radius of the sun into space, 500,000 miles. So the picture that you see on the screen here, if you're watching, is a prominence seen in true color during a total solar eclipse. And if you see obviously the big blacked out circle, there's the sun, and then around the edge you can see these red, like, flame looking things, and that's a prominence. So in a total solar eclipse, you can see these things naked eye if they're big enough. Obviously, I shouldn't have to say this, but don't look at the sun even during a total solar eclipse. Make sure you have eclipse viewing glasses or filters on your cameras and your telescopes if you're doing it. So the term prominence was actually first found in something called the Laurentian Codex from the 14th century, and they were describing a solar eclipse that happened in May of 1185. And the description that was used was flame-like tongues of live embers. So here we are in the 1100s, and people are describing these solar prominences. And there's different ways to classify prominences, but the most common way to do it is based on the magnetic environment, how strong their magnetic field is that's holding it in place, that's causing it. So we have active, intermediate, and quiescent. So an active region filament, prominences can also be called filaments. An active one would be from a strong magnetic area, intermediate would be a medium strength, and quiescent would be a weak magnetic field. So if you're looking at the screen, if you're watching this, there's a picture of the sun, and the three different areas are labeled. So the ARF is the active region filament, and it's a very bright white area. So the brighter the spot on the sun, the stronger the magnetic field. And then IF is the intermediate filament, and then down on the bottom there's a QF for quiescent filament, and that's a dark region. So anywhere you see dark spots on the sun, like a sunspot, it's cooler regions. It's weaker magnetic field, cooler temperature. So when a prominence, when it erupts from the sun, it becomes ejected, it can reach speeds of up to 1,000 kilometers per second. And about 70% of these prominences actually become the CMEs, the coronal mass ejections. Usually CMEs are associated with solar flares. I didn't get into solar flares and all that, but we can do that later if you guys want. So right now what's going on is, so this is a picture of the sun captured on July 12th. So this is a very large prominence. It's being monitored around the world, because if this does turn into a CME, it would be a pretty big deal. And it could produce a very strong magnetic storm on Earth. Sometimes these storms will last for days, where you just have, most often you'll just see it in the poles. It'll be like aurora, like so you'll see like the aurora borealis, and it will just very often extend much farther south. There have been times where here in Iowa we've been able to see it, which is rare. I think there were times when, farther south, I think even like as far south as Georgia one time could see them, the northern lights, which is very unusual. So if you're looking at the picture here on the upper left limb of the sun is that big huge solar prominence. The big red splotch on the edge of the sun is the big one that we're watching. And then you can see there's some other ones all around the edge on the right side. So there's different smaller filaments, prominences going on. And all these dark regions would be, if they're kind of stringy looking, that's a filament that you're just looking at like from the top view. The red ones that you see around the edge are just same thing, but from an edge on sideways view. And then you can see some sunspots on there. So I'm going to bring up something in just a second here, because as I'm looking at this picture, I'm wondering about this coronal hole we're going to talk about, because I don't know if I got the date of that one. Alright, so the coronal hole. So this is the picture that's going on right here. Okay, so this was done on July 14th. So what I don't understand is on this previous picture, we don't see it, and I don't know, the sun doesn't rotate that fast, so I don't know. It makes a full rotation, you know how the Earth does 24 hours, as in a rotation. It takes the sun about, I think, 28 days, or 27, for the equator. Because the sun has differential rotation, because it's plasma, it's not a solid sphere, it's plasma. The equator rotates, I'm going to get this wrong, slower than the poles. It should, I'm pretty sure. So I think the equator rotates at about 28 days. So the picture that I'm showing you right now is with the prominence that was on July 12th, and then this one is the coronal hole on July 14th. It could be it's a different filter. So I'll click on some links in a second here and we can look into that. So in this picture you see there's a gigantic black region at the bottom, the southern part of the sun. That's a huge hole in the, I guess if it's a corona, then yeah, we wouldn't see it on the other one, because the other one was probably the photosphere. I bet that's it. So the corona is a region above the sun, where a lot of the solar wind, the magnetic fields get weird in the corona. So that must be what this is here. I'm sorry, I didn't get that first. So we have this big, huge coronal hole. It's kind of a big deal because these are areas where the solar wind can escape from the surface of the sun. And if you have a large area like this, then a lot of that wind can escape very quickly, and it can hit Earth and cause the geomagnetic storms, as well as, it doesn't have to be a huge solar flare event. It can just be a coronal hole like this that just allows the solar wind. Solar wind is always going on. But when you have holes like this in the corona, it just lets it escape out really fast, kind of like if you are suddenly puncturing a balloon and the air just escapes out of a hole much faster. The bigger the hole, the faster the air can get out. So this is a big deal because they're not normally seen at this scale, and holes this big can cause storms that last for days on Earth as the wind just keeps blasting out of it. So here are some links if you ever want to get into space weather. Let me just talk about this picture real quick, because this is something that's fun to see. It's very rare to see something like this, and this was captured on July 13th of this year in South Italy. So what it is if you can see, there's a little green line just above the horizon, and that's what's called the green flash at dawn. And I think so in Pirates of the Caribbean they do this, and I think they do it as sunset. I've only ever heard it, I think it's sunset. I don't know if it happens at both, or if in the movie they just did it because it was more theatric to have it at sunset. So as the sun is setting, or I guess in this case it was rising, there's sometimes a green flash on the horizon. And it's very rare to see, and it's an optical event. I know I looked this up. I don't remember what exactly is causing it to be green. I think it's just the angle, the way the light goes through the atmosphere. And so somebody captured it here, and I just thought it was really cool because this doesn't happen very often. And I just like that in the Pirates of the Caribbean they used it, and I don't remember what it was signifying. A soul being captured by Davy Jones or something. But I thought it was kind of fun because if you didn't know, that's an actual event. And so if you just watch the movie, you're just kind of like, oh, okay, cool, green flash. They exaggerate it quite a bit in the movie. It doesn't, I don't think, look as dramatic as they did it. But it is very rare. And I just thought it was cool that they did that because it is an actual event that does happen. So I thought that picture was really cool to go along with space weather. So here's some links, spaceweather.com. And let's see. And then, of course, NOAA, National Oceanic and Atmospheric Administration, Space Weather Prediction Center, the Solar Dynamics Observatory, also it's a NASA organization, and the Solar and Heliospheric Observatory, or SOHO. Let's see if we got any of these. There we go. So here's spaceweather.com, which I kind of like. So they've got, here they're talking about, the Dragon 4 capsule. So that's kind of cool. Bastille Day event 25 years later. Let's see. I'm just going to read this a second. 25 years ago, on July 14th, 2000, the sun unleashed one of the most powerful solar storms of the space age. It was so intense, its shockwaves rippled all the way to the edge of the solar system. Voyager 2 felt the explosion 180 days later. The debris was still coherent and traveling faster than 1.9 million miles per hour when it slammed into the two spacecraft, Voyager 1 and 2. And they were more than 9 billion kilometers from the sun, and the solar storm was still going 1.9 million miles per hour when it was 9 billion kilometers from the sun. Wow. Okay, so here then it says that here on Earth the effects were almost immediate. Within minutes, extreme ultraviolet and X-ray radiation bathed the planet and its satellites. Wow, so that's pretty cool. So The flare happened on July 14th. It's called Bastille Day event, after France's national holiday. So then, I'm just kind of scrolling through here. Sorry guys, I'm just kind of reading it. So I love the space weather stuff. It's fascinating. So this is a good site. I mean, there's a lot of information on this one. And then they've got some cool jewelry apparently. Pearls with altitude, white cat earrings. So on July 7th, 2025, these earrings hitched a ride into the stratosphere on board an Earth-to-Sky cosmic ray research balloon. So you can buy these earrings that have been into, I don't know about space, but high altitude. Yeah. So that's pretty cool. So then they've got just a bunch of stuff on the side. You can look at the sun, near Earth asteroids. They've got the space weather forecast from NOAA here on the sidebar. So spaceweather.com is a good place to go if you just want kind of an overall look at what's going on. They've got where you can see auroras, how far down those are going, cosmic rays, the sunspot counts, all that. So here they've got a picture of the sun right now. Oh, not found. Okay, well, we'll go somewhere else and get it. Alright, so this is SOHO, the Solar and Heliospheric Observatory. Same sort of thing. It's all about the sun. That's all you're going to find here. So they've got solar wind, they've got space weather gallery, the sun now, sunspots. So if you click on the sun now, you can look at it in different filters. So there's different colors that you can look at. So the one we always liked was the HMI continuum, which is just the yellow disk with the sunspots on it. So there's a few sunspots, the dark spots on the sun. So I always loved this site. When we were in astronomy in school, we would use this quite a bit. And then last would be the SDO, the Solar Dynamics Observatory. So this is just a satellite that orbits and studies the sun. So it's kind of fun. The flareometer is at X level again. That was in June. So, a lot of good stuff on those sites if you're interested in the sun and space weather. Alright, so that is our kind of science section for the day. So next we'll move on to the nature of light. We're going to do some physics of light here. But then I'm going to get into, the spiritual side of light as well. So I love prisms. Again, it's light. I love the fact that you just take a regular light, you shine it through a prism, and then you get a rainbow on the other side. I love prisms and optics. So first of all, we're just going to talk a little bit about what is light. So if you don't know, light is electromagnetic radiation. So there's a whole spectrum of radiation. Every type of radiation is on the spectrum called the electromagnetic spectrum, or EM radiation, EM spectrum. The very shortest wavelengths are called gamma rays. Those are usually what we find from the sun, from space. And then the longest ones are radio waves. And so somewhere on that short end you'll find things like UV rays. So it's those ultraviolet rays from the sun that can burn your skin because they're such short wavelengths that they can penetrate through your skin and burn you. Radio waves are very long. They're on the order of, I think, several meters, so they can't get through your skin. So that's why radio waves don't hurt you. And so visible light is a very tiny section of that entire EM spectrum. Visible light is a very narrow band. It ranges from about 380 nanometers. That would be your the violet, the purple side, and then up to 750 nanometers on the red. So you've only got about 400 nanometers of wavelength. That's what we see. So our entire world that we see is contained in about 400 nanometers of wavelengths. And a nanometer is 10 to the minus 9 meters. So very small, very short range of the spectrum, and that's all that gives us our entire world that we see. So the fascinating thing about light is that it has this thing called particle wave duality. So that means that light behaves as both a particle, like a ball, like an actual discrete individual unit, and as a wave, like a continuous motion, a continuous energy. It does both. So if you describe it as a wave, you get things like diffraction, which if you see, you put something in a glass of water and it looks like it's bent. You put a spoon in there, or a pencil, pen, and it looks like it's bent. That's because of diffraction. Because light is acting like a wave to do that. Or interference, you have two waves. The example I have here is they're coming in opposite directions. So if it's the same amplitude, different directions, they'll cancel each other out. They can interfere with each other and then cancel out and you get nothing. Or they can add together and then you get a bigger wave. So you have interference, you might talk about interference with your radio, or back in the day when you had TV with the rabbit ears and the static, that was all interference. And that was because, well, that would be, yeah, maybe not exactly light, but waves interfere. Waves can have constructive or destructive interference, and so light can do that because it acts like a wave. Polarized sunglasses will work this way. If you have two polarized sunglasses and you put them together, it'll actually completely block out everything because the waves are interfering and they cancel each other out. So if it's acting like a particle, which we call a photon, you have things like the photoelectric effect. So that's where you may have a material, when it absorbs EM radiation, light, heat, whatever you were doing, in this case light, electrons will be emitted from that material. And it basically, the incoming radiation would heat up the particles, and then they emit the electrons from that particle, or from that material. So the photoelectric effect is often studied in fields like solid state physics and quantum chemistry. But that should only happen if light is acting like a particle. So the photoelectric effect contradicts classical physics. So what should happen is that the electrons should only be emitted from that material when they've absorbed enough energy to raise up into a higher energy orbital and then basically eject off of that material. So more intense light should mean faster transition than dimmer light, because if it's more intense, they're going to heat up faster, or absorb more energy faster, and then they'll be emitted faster. But that's not what happens. So what does happen is that electrons are emitted independent of the light strength. It doesn't matter if it's a very intense light or a very dim light. The only thing that matters is the frequency. So frequency would be if it's ultraviolet or infrared. It's that wavelength that matters, which doesn't make sense because then you could have a low intensity light, very dim, but very high frequency, and it doesn't matter. You could have very strong light, but very long wavelength. That doesn't, the strength doesn't matter. It's just the wavelength. And that was contradictory. People do not understand that. I don't think they still understand why it happens. They just know that it does. So, I guess now we know because this is the particle part. I don't remember. Oh yeah, so we'll get to this in the 20s and 30s, I guess this was going on. So because low frequency light, so low frequency would be your long wavelengths, so like your radio waves, the red on the visible spectrum. Low frequency light at high intensity does not produce the expected results. And it should. They were thinking the intensity is what should do it. But that didn't work. So Einstein proposed that light is not a wave, but are these what we call packets of energy, these little discrete units, these packets of energy. And these packets are called photons. And that term was coined in 1926 by Gilbert Lewis. And there's a few other. The classical example, I didn't put it in here, is the slit experiment. So if you have a very narrow slit in a screen and you shine light through it, you'll see that you'll get a diffraction pattern, but there'll be like discrete, essentially bands of light on the other side of the slit. So it hits the slit, as an even uniform beam of light, like if you have a flashlight. The entire wall will light up if you shine a flashlight at a wall because the light nature, or the wave nature. But if it goes to this little tiny slit, on the other side of that slit you see bands of light and dark, as if discrete individual units of light were collecting in bands of light, like a particle. So I should have put that, I don't know why I didn't put that one in here. So light is not one or the other, it's both. And I've always found this fascinating, because you don't know. And it's just kind of fun that it's not one or the other. And I think often in science you're like, well, if something contradicts a theory, then we have to abandon the theory, or we have to choose one or the other. Is it the old theory but the observation was wrong, or is it the observation and the theory is wrong? You got to pick. But light is not. Light is both. It's like, nope, you don't have to pick, you get them both. So even we see that science doesn't always have this neat arrangement of things into a single category. Oftentimes you have to basically hold two truths at once. And then we have these paradoxes too when you get into the speed of light and relativity and all that. That's a lot more theoretical. Light, you can actually see the effects. You can see this dual nature in the lab, in an experiment. And this has always reminded me of one of my favorite quotes. I think I've probably mentioned this before. I first heard it in I think it was Rob Zombie. It's either White Zombie or Rob Zombie. I don't remember which one. But the quote is, "Look, I know the supernatural is something that isn't supposed to happen, but it does happen." And it's actually from a 1960s horror movie called The Haunting. But I've always liked that quote. And I was just the other day, I was talking about something that was going on at work, because it's like, yeah, I know something shouldn't work, but it does work. I know that shouldn't fix the problem, but it did. So these types of things go on all the time. So that's one reason I really like this topic of light, because it's very mysterious. I mean, mysterious, we've got it figured out. Like we have it that it does a particle and a wave, but like how and why? How did it do that? And then the people have figured it out. I mean, I'm amazed at how smart people are and how inventive the human mind is to figure out solutions to these problems. All right, so next we're going to talk about kind of the spiritual side of here. So light has always been a metaphor for spirituality. And throughout history, you've always used light as a metaphor for truth or clarity, awareness, divinity. You have halos around angels. You say things like, I saw the light, when you have a realization, when you see the truth of something, you saw the light. You might tell somebody to shine your light, you light up my life. Light has always been used for these sorts of, healing, divine awareness topics. And in John 8:12, Jesus says, I am the light of the world, meaning that he was the spiritual truth in the world. So light is always used for these very positive, uplifting things. And we can talk about receiving and radiating this like spiritual inner light, kind of the photoelectric effect. A material receives light and it radiates energy. So we can receive spiritual light by doing things like meditation, prayer. You tune into your inner clarity and you become enlightened. And then you can radiate that spiritual light through your acts of service, teaching, creativity. Anytime you interact with somebody and you kind of bring that light, that awareness to the world, you share that inner light. So we can sort of act like, a light in the physical light, the physical materials that absorb light, that radiate light. We can do the same thing with our own inner light, by receiving and radiating spirituality and our inner light. So what if our inner light is just as dual in nature as physical light? So we need that quiet reflection where we just, sit, be still, kind of cultivate, find that inner light, that peace, the clarity, the awareness. And then we also have to be, or shine, this outward brilliance. We have to, once we find that inner peace and that clarity, it doesn't do much good to hold on to it. So you want to radiate it, you want to show it and bring it to the world. You want to be brilliant, you want to be that beacon, that light for everyone else. So a couple things to reflect on, and if you're watching, there's a picture of an actual reflection and then a meditation, a yoga reflection. And one of my favorite things is lamas doing yoga. So namaste. So a couple questions to think about. If you're into journaling, if you're into meditation, I like these questions. Where am I being asked to shine more brightly in my life? So is it in your work, your relationships, your creativity? You have projects that you're working on, you want to shine more brightly. And then what's one small way you could switch on the light this week? For me, I definitely need to shine more brightly at basically in my home life. I think just the other day I was so tired. I just didn't feel like doing anything. And of course my little kiddo wants to go do all the things, and I did not want to do it. I was so tired, very dim. I felt like my light had been turned off. And I felt really bad because, it's such nice out. Yeah, it's super hot and humid and disgusting out, but it's summertime. That's what summertime is. Kiddo just wants to go outside and play, wants to go to the park, and I just was like, not today, I can't. So, and I felt really bad about that. I feel very guilty still about it. So it would be nice to, have a little more light, a little more energy to do more of the things that, make someone else happy. And what's one small way I could switch on this week? Well, certainly going to the park. Taking some time to just, do whatever, the kiddo wants to do. Just for a day. Just for a few hours. It's just going to the park. I used to love going outside, going to the park, being outside all day, even in the summer. But, things have changed. So, I need to work on that. But today's Tuesday, so I've got a couple more days here to try to get that light turned on. All right, if you guys want to share, if you feel like sharing, I'd love to hear. You can find me on Facebook, YouTube, Instagram, website. So here's a couple sky watching resources. This I think is on every episode, so I haven't updated them yet, but these three are ones I always like to use. Time and date isn't necessary. It's not just astronomy. In fact, it's not really astronomy at all. It's just time and date. But they have a lot of, if there's astronomical events going on, your eclipses. I often go there for that because it's really easy. You type in where you are, done. But they've got times and dates for everything across the world. Sky and Telescope is my favorite for their interactive sky chart. And then space.com. And space.com has obviously just everything you want about space. So if you're interested in just learning more about space or sky watching, those are three good places to go. And then spaceweather.com for space weather. NASA and NOAA both have space weather as well. And I've got a book out just to remind you guys if you're interested in kind of combining spirit with science. The easiest place is on Amazon for it as an ebook. I have the PDF files actually look better. The PDF files are what I intended the book to look like. They just don't translate into the ebook format. So I had to take out a lot of the imagery. So if you want, the PDF's kind of the full effect, the full experience of the book. And those are on my website and the Etsy shop. It's the same price as the ebook. The only problem is that I think they broke them to like 5 PDF files because they were too big. So let me know if you have any questions about that. And then, of course, you can follow me at all the usual places. And if you'll indulge me one more time, I'm going to go back to my website, maybe. I didn't link anything here. Well, so if you go to the website, this window pops up if you want to get a 7-day cosmic reflection journal. So it's just 7 days of journaling prompts. And you can sign up for the newsletter. You can get that journal, and then there's a section on the website when you subscribe to the newsletter. I'll give you a link for subscribers only. So anytime I post or make exclusive content for you guys that subscribe, it'll go there and you'll have a link to it. And then the newsletter is it's one section about the electric universe theory, one section about physics, one about astronomy, and one about spirituality. So then those are the 4 pillars of the interested reader. So those 4 things. So if you're on the website and you click on any of these 4 topics, you can go to the blog site about it. So if you click on physics, there's a couple different blogs here. Of course, images don't always load. So my most recent one was The Science of Stillness, Why Pausing is Powerful. And eventually I'll have a lot more. There'll be workbooks and activities and quizzes for each of those sections, but that's how you navigate there. If you go to the resources tab, you can go to workbooks and worksheets, and there's a few things over here. Right now it's mainly just a problem-solving guide, I think. But I'm always working on getting more things up and posted, so. But you can subscribe to the newsletter with that pop-up screen that comes up, or if you go about, oh, there it is right there. If you go to midway, on the home page, there's a button, subscribe to the newsletter. And then you can just sign up there if you want. I do it monthly right now, so. Or if there's something specific that I create just for subscribers. Usually it's going to be like journals, because I love journaling. And that's about all I've done so far. Usually it's just a journal that I'm creating. But if you guys want something else, I like to do infographics too. I just did one about fireworks for the 4th of July. That's posted on Instagram. So you can find me in all these places. Alright, well, I think that's all I got for you guys. If you have any questions, let me know. There's Instagram, Facebook. If you just search any of these things for the interested reader, YouTube. I'd appreciate if you guys if you're listening to this, if you're so inclined, to leave a comment or a like on YouTube. I don't think I think I have 1 like out of all the episodes. I've only done 18 episodes, but I think there's only 1 like. I mean, if you don't like it, do that too. I don't care. I'm just like, I just want some engagement. I want somebody to comment. Give me a comment. Tell me something. And yeah, you can be just brutally honest. Tell me what you're thinking. If you don't like it, that's great. If you do, even better. But yeah, I'd just love to hear what you guys are thinking. If you like it, if you don't like it, if you want a certain topic, I don't know. Just let me know. There's different ways to get a hold of me. And there's always email, sarah@theinterestedreader.com. All right. I will talk to you guys later. I have this planned where I'm going to do another podcast in, I think, 2 weeks. I'm going to try to do 2 a month. That's the goal. And I'm actually using ChatGPT to help me stay on track. I had the chat bot create basically a timeline and a plan, a 3-month plan, a 1-month plan. This is what you're going to do this week. So this week was to publish a podcast, and then I think again on week 4 it's actually written down that I'm going to do another one, so hopefully that keeps me on track. We'll see. I do like using ChatGPT. That's kind of fun. So anyway, I will talk to you guys in about 2 weeks, and have a good day, have a good week, let your light shine, and I will talk to you later. Thanks guys. Bye. I hope you enjoyed this episode and are inspired to question and investigate the world around you. Let me know what you're thinking about. You can contact me through the website, theinterestedreader.com, send me an email at sarah@theinterestedreader.com, or join the Interested Reader group on Facebook. I'll see you at some later time T, where T is greater than T naught, and T naught is equal to now. Thanks for being an interested reader, and I'll see you next time.